Greetings, Earthlings. Welcome back to the Art of Math. In today's video, which will be about math as a skill versus math as an art, meditation, and form of play, we're going to go over several things. So let's jump in. First of all, up to now, just to recap, we've been doing a lot of algebra videos. So the name of the series is The Art of Math. And so I want to make the next few videos really highlight that. So we're going to take a little bit of a break, or rather, like, we're basically done with the algebra almost. So we're going to do several videos highlighting the art part of the art of math. And then we're going to do a final algebra video, which will deal with substitution. And then we'll begin our geometry chapter. So you can just think of these next few videos as kind of like a break between the core skill building things that you might need for school. But I find these next few personally like super fascinating, and I really encourage that you don't skip them and just go for the pure skill videos. All right, so the plan for the next few videos is to go over topics that are outside of the traditional curriculum and that are going to showcase this beauty or the art part of math. So up to now, you guys have probably gotten a sense that the videos have been focused a little more on skill building. So take a topic such as exponents, and I want to just get you guys really good, really fast, or at least start you off right with a good foundation. So that's sort of like been 80% of the focus, if not more. And so, it seems like maybe this series has a misleading title because it's the art of math. So we've been doing more of this versus math as an art, meditation, and play. So in the next few videos, and as well as going forward in the series in the geometry chapter and beyond, I want to really focus a little bit more on, so there'll still be a ton of skill building, but I want to make it a point to focus on this. So I'm gonna be honest. So like my obvious goal, like my direct goal, has been to help you guys with the skills, but I've had a more subtle goal, which is to increase your appreciation so you can see the beauty of math and just have fun with it and explore. So I haven't always necessarily done a great job at that, but but one of the reasons I love math is that I find it exciting, and it's just, there's so much awesome stuff there. So I want to show you guys some of that beauty. And here's the thing, you don't have to be, I just want you guys to see that there is a lot of beauty in mathematics. Just like, you can dislike a genre of music, but you can know that a lot of people really love that genre. So whether you already love math or you're not sure, you're just trying to get through your math class or whatever it is, my hope is that you can glean some of the fire, some of that raw energy, how alive math can be. So that's kind of what I want to get across. And so I've had sort of 3 goals in this series just to make it real. I really want to state it for you guys. Like I said, skill building, that's probably what most of you, have come here for initially. But that's not what really gets me sort of excited to make these videos. There's math as an art, which is just like the beauty of it. Again, when I say art, that includes meditation, play, all of that other stuff. But then there's like a third one, which is really the one that super drives me forward. But I don't really make it a point. I haven't made a point too much of shoving this in your face. So this is kind of behind the scenes, which is the general development of the student. I mean, like, math is pointless if it doesn't help you as a person. So, math is only a tool. It can help you develop and practice critical thinking, problem solving, creativity, but also like really more important things like such as empathy, loving your fellow, student, and all that kind of stuff. So these are kind of the 3 goals, from the most obvious ones to the less tangible ones, but hopefully there's a little bit of all 3 happening in this series. So those are just to let you guys know. And they're interrelated, so it's hard to really appreciate math if you haven't. You will. There are a few basic things, but the more skills you've developed, the more you can appreciate the beauty because now you sort of know more things to look for. All right, so that's what I want to mention there. Now, in terms of this other aspect of math, the math as an art, so as an art, meditation, or play, as an art, I've given, so this one example earlier in the series, it wasn't a really great example, and that's why I'm going to provide much better examples in the next few videos. But the example was x to the 0th power. Why is that 1? So that's a great question. In fact, there is no reason why it's 1. Mathematicians just decided to make it 1. So I liken it to a game of freeze tag. If you're playing freeze tag with your friends, or tag, whatever, you can make you could decide to change the rules, like this is base or that's not base. You could hold on to it for 2 minutes. But if you make silly rules like, hey, I can hold on to base for forever, then the game is no longer fun. So you could define this to be 7 if you wanted it, or like -2, whatever. But then it wouldn't be as fun. So what do I mean? It's also not as useful, but if you look at x to the 0.001 power, x could be any number, let's say 7. 7 to the 0.001 power, this is going to be pretty small. And x to the negative 0.001 power, that's also going to be pretty small. So you can find what these values will be, and then hopefully if you pick an exponent in between these two, which is 0, the number that x to the 0 should be between these two. That makes it kind of like a smooth curve. I'm sorry I had this tiny diagram, but that way this exponential curve, which looks like that, would be 1. So if you just mess around with numbers, you'll see that 1 is the most sort of fun or reasonable or useful value. So it is made up, but we get the most mileage out of it. So in that sense, someone just decided, hey, this would be a fun, like for example, if you say you can only hold on to base for 10 seconds, that makes it fun. If you make it 1 second, that's too fast. If you make it, 10 minutes is way too boring. So like I said, there'll be more examples to come. But also math as a meditation, so math as an art. There's so much beauty in nature and art, and I want to just not mention it like in such vague words, but actually discuss that in the future videos, as you guys will see. Math as a meditation, so just observing nature, art, thoughts, reality. So like looking at trees outside, and we'll get into the specifics of what I mean by trees. So just like any form of like actual physical meditation, math can be a form of a mental meditation. Now, or visual meditate, not just inside your head. So then math is a form of play. It can be discovery, fun, making up rules. So like you can make up any rules you want. Like, hey, if I do x to the 30th power, like 7 to the 30th power, I'll call that 5, and then examine the effects. Oh, well, that's not really fun, just like the freeze tag example. So actually the idea of math as an art and math as play, and even skill building. So like think of skill building as gymnastics, right? So you have physical gymnastics where you do backflips and all that stuff, but then you have mental gymnastics. So the more skills you have, the better you are at that gymnastics. So it's more fun to play when you have more skills, and it's just like an artist, right? If you haven't learned your craft, you don't know how to paint a face that looks like a human face, you're not going to have as much fun. Or if you're playing tennis, if you don't know how to hold the racket, the better you get at something, the more skills you have, the more fun you can have, the more you could treat it as an art. So these are all interrelated. So that's the point I'm trying to get across. But I don't want you guys to just, whether it's due to some bad experiences in school or whatever, to view it as this boring thing that you just have to get through and just, I guess you can get a job with it, it's good for that and make money, whatever. But there's this beauty to it. All right, so enough said on that high level. So let's get into the specific layout for the next few videos. So I'm going to focus specifically, like I could have done a lot of things, but I kind of wanted it to have some sort of structure, yet touch on some of the really highlights that I love. Okay, so I'm going to title it Math in Nature and Art. So the next few videos will have little sections. By the way, each section might have more than one video, we'll see. but just so you guys have a sense and can follow the next few videos. So we'll have comparing infinities. So I'm sure you guys have heard of infinity, but I don't know, I'll leave it at that. So there's a lot of stuff we can do there. Fibonacci numbers, many of you have probably heard of that. The golden ratio, chaos theory, fractals. One of my personal favorite things, probably the most obvious example of art in math, like specifically art, not just metaphorically. And a lot of these are interrelated, so chaos theory and fractal. So that's why I put a lot of these together. Synchronization and swarm behavior, and then some random topics and questions. So this is just to give you guys just a few things to look into. So, and on the right structure. So how are these videos going to function? I'm basically going to introduce you guys to some of these topics and probably not even do such a great job, but just give you a sense. So I'm going to introduce you guys, give you some highlights, some things that I like about these things. And that's really like 1%. So then the plus. Then the next part, and this is the critical part, I'm going to try to post for some of them more, some of them fewer links, but especially like the fractals section, I'm trying to post lots of links in the description, so make sure to check all the descriptions so that you can explore them more on your own. So, for example, I might go into like 1 or 2 fractals, but really this is the fun part. So, you know, if you watch the video and then you're like, oh, okay, I got it, that's just 1%. All right, so I really encourage you, please check the descriptions and mess around. Whatever you don't have to go through everything in the descriptions, but poke around. Like eventually you might want to hit everything or just take a peek at everything, but you might find that one link catches your interest, or you found things that I haven't linked to at all, or one link led you to another link, or you asked your teacher, your friend, your parent. So yeah, please do that exploration. I'm hoping to just get you guys started on this journey of things that are sort of outside of traditional, 2 plus 5 and just useful kind of math that you'll see in like engineering and math and life. More of the beauty side. All right, so that's the plan for those videos. And then we'll finally wrap up with applying some of the stuff, specifically the fractal stuff, to a actual set of tricky math questions. And this will be one of my favorite things in all of math. All right, that's the plan. I will see you guys in the next few videos.